All right, guys, we are going to continue in lesson 1.4. We're going to do the activity that says reteach transformations of absolute value and quadratic functions. Do the math. So the do the math, you should try to do this first, and then if you can't figure these out, kind of come back to the video to get help. But if I were you, I would pause the video, try to do this first, and then let me walk it through you if there's something that you can't get on your own. All right, it says please click start. So we're going to look at this, and it says find the equation for the transformation function g of x when given the graph of the parent function, which is f of x equals the absolute value of x. Okay, so the first thing we're going to do is see that the one on the left is our parent function. That's my absolute value of x. It goes through the origin, and that is the parent function. So that's your f of x. And then this is your transformation. So you can automatically see that the vertex has moved from 0, 0 to 3, 1. So we can go ahead and use that in our equation. So we know that y equals, let's put an a here, and then absolute value, x minus h plus k, and hk, remember, is our vertex. And for this one, our vertex is 3, 1. So that is 0.31. So that means we're going to put in y equals a, and then we have x. Minus is part of the equation, so minus 3, and then plus 1. So all I did was substitute my vertex in for h and k. Now I want to find a, so let's find another point. So there's a point right here. So that is 1, 5. That looks like 1, 5. So that's an xy coordinate. So I'm going to plug in 5. I still have a. That's what I'm looking for right now. And then I'm going to plug in my x, which is 1. Don't know why I wrote a 2 there. Let me back up. Alright, so I've got 5 equals a. 1 minus 3 is negative 2. Absolute value of negative 2 is 2. I'm going to subtract 1. So I've got 4 equals a2 or 2a. Typically we write the number first. So a equals 4 divided by 2 or 2. Alright, so we're going to take a. We're going to substitute that in our formula here, and that should be our equation. So we're going to have g of x instead of y, it's g of x, but that's okay. So we're going to have 2 absolute value of x minus 3, arrow outside the absolute value, and plus 1. Okay, let's see if that works. And it does. So that's our equation for the transformation of g of x. All right, a cross-section of a curved bowl can be modeled by a quadratic function. Use the given information in the graph to write a quadratic function that represents the curve of the bowl. All right, so very similar. Remember, a quadratic is a U-shaped graph. So we got parentheses squared, but we still have h and k, where h and k is our vertex. All right, so if we come over here, we can see that our vertex is 1, 3. So that's our h and our k. We're going to have y equals x minus 1 is our h, and then plus 3. Now we're going to use one of these other points. It doesn't matter which one. Let's just use 4, 4. So we're going to plug in 4 for y, and we're going to plug in 4 for x. And that way it only leaves a, so we can solve for a. So we're going to have 4 equals a times 4 minus 1 is 3. 3 squared. Bring down the 3. So I'm going to subtract 3. 4 minus 3 is 1. 3 squared is 9, so we've got 9 times a. And divide by 9. So a equals 1/9. Alright, so just like before, we're going to substitute the a back into this equation, because we already have put the vertex in there. All we needed was the a, and that's going to be the function that we put. So we're going to do 1/9. Then I'm going to do parentheses x minus 1. And then, let's see. Do I have a squared button? Here we go. And then plus 3. And so that's your equation. So we just wrote an equation using 2 of the points, using your vertex and another point to find the equation. All right, now it says state the domain of the function. All right, domain we learned, in a couple lessons ago. Your domain goes from all your x values. So it goes from -2 to +4. So our domain is the x, all the x's. So it goes from -2 to +4. So we're going to put in -2 and 4, and that should be correct, and it is. All right, and that's all there is for this lesson. So if you have any questions, let me know.